What is going on, everybody? Welcome to Cup of Code 01. For today's video, you will notice there is no camera, so you do not have to look at my ugly mug. With that being said, let's jump right into it. You can see on the screen we already have a file open. This file is named split.py because that was when I was working on the Pi game Hangman. We started utilizing .split, some dictionary pieces, and I felt it appropriate just to make a separate file that would kind of go over these. So we're going to run through the debugger now so you can kind of get an idea of what works, what doesn't work, and how you can manipulate these things so you can use them in any of your own projects. So with that being said, let's jump right into it. So you can see up top here, we're starting on the line number 2, x equals blue, red, green. Now we just have those in quotes. So we have a string, blue, comma, red, comma, green. The comma is important because then we're putting on the method, the .split method. And then what we have here in parentheses is we're telling split that what we want broken up is separated by a comma. And what this is going to do is it's going to output a list. So it's going to make a list for us utilizing these 3 or however many inputs you have on a .split. So when we're doing the Hangman game, we have just a string, not even separated by commas, separated by spaces. So if I had this as spaces, if I had it like this, then I would just have to correspondingly make it a space so that I'm telling split that my pieces I want broken up are broken up already by spaces. And then this is going to create a list for us. What the hell, we'll keep it that way. And we can run through and debug. So as you can see, it did create a list. We'll go across here. Where are you? Blue, red, green. So you can see we have our brackets. So it is a list, and they're separated still by the commas, but now they're individualized. So now we could, now when we call X, we can manipulate a list as we do and not have to worry about it being a string. Just makes it easier to type things in a string than it does as a list. That's why we're utilizing the .split there. So all we did here was print that out. So we're going to see on our console to the right, it's going to print out now the list that we created. And again, this was just a string that we used the .split, and we had to tell the split how it was being separated so that it knew. And just for proof, we're putting a print type, and it is a list. Next, I'm just showing how we can do assignments. So we have A, comma B, comma C equals X. And then I'm saying print A, B, and C. So looking at this right now, we already have a variable X up top, and it has currently in memory, it has this. It has blue, red, green in a list. So if I have A, B, C equals X, I'm saying A, B, C equals blue, red, and green. So what do you think is going to happen assignment-wise when we go through a print A, B, and C? Well, we can do that now, and you can see in memory it associated A to blue, B to red, and C to green. And now what does this look like to you? Where we have a value with a colon and then a string piece. This is looking very much like a dictionary. So what it did was it did one-by-one assignment where the first parameter in the 0 index in my assignment was tagged to the 0 index in the list. The 1 index was tagged to the 1 index, and the 2 index was tagged to the 2 index. So A, B, and C is now going to be blue, red, and green. So we look in our outpost, and sure enough, blue, red, and green. I just want to show here that words, we created a variable and I put a string. This is a random text we are going to split apart, .split. And how is this separated? Do we have commas? No, we're telling split we're separated by a space. And I'm saying print words, so it's going to give me a list of each individualized element broken up into its own element piece. And of course, this would be index if I had to call it 0, 1, 2, 3, 4, and so on. And all the properties that we utilize for list in terms of adding, deleting, manipulating, reversing, we can do that with this list that we created. We could not have done that when it was a string here because there's no indexing for this. If I index this string, I'd get the entire string, and you can't index a string in that regard. Why is this important when we get to natural language processing? This is going to be hugely important. I just finished a Udacity Nano degree where we were doing TV scripts. Excuse me. And on the TV scripts, you have to break words apart like this and create the words, quote unquote, as integers. That's how the computer can get patterns. So I put print, write me a sentence. So now I'm showing you that you can use input. So I'm putting input, write me a sentence. So we printed write me a sentence. It's waiting now for input. This is a sentence that we will split, enter, and sure enough with the .split, and I told it by spaces because I wrote it in spaces, this is a sentence that we will split, and it created a list for me. Moving forward, I just threw this part of dictionaries in because we were utilizing split, and then dictionaries was part of a Hangman advanced part, so I just threw it in this. You might as well go through it as well. It's a good refresher for dictionaries, and it's multiple assignments and dictionaries can be very similar, as you can see up top here, where I had multiple assignments tying it to a split list, and it created those assignments for us. So now we're creating a dictionary. Does dict equals, and then dictionaries always have a key and a value. So the key, and then we have the colon, and then we have a string, not always a string, but a string here that's going to give it the value. So key of 1 is always going to be tied to the value tree. The key of 2 is always going to be tied to the value of apple, and the key of key is always going to be tied to the value of this is a value. Now, one of the important factors with dictionaries is the order does not matter, and we'll see that later. Order means nothing for dictionaries. However, 1 will always be tied to tree. And again, this is the integer 1. Notice how I didn't put quotes here. This is integer 1, and this is the string 2. Just saying. So 1's always going to be tied to tree, 2's always going to be tied to apple, key is always going to be tied to this is a value, of course, unless we adjudicate that or amend it. So we're going to go through. I'm putting, you can see here in memory, it created a dictionary and it's saying 1 tree key, this is a value 2 apple. Now look, even in memory, it already switched the order. So 1 is tree, that's correct. 1 is tree, 2 is apple. Well, no, now index 1 is key, where index 1 used to be 2 apple. So you can see how it already switched the order up on us. So we're printing, this is the length of the dictionary, comma, string length. I had to put the string in because this would have given me an error otherwise. So I'm saying get the length of the dictionary and convert that to a string and then print that after this is the length of the dictionary. So this is the length of the dictionary, 3. And sure enough, we have element 1, element 2, and element 3 because key and values go in pairs. Going down here, print the list of dictionary keys. So print list dict.keys, and then I have open in quotes because I wanted to do the full run, and show it gives me 1 key and 2. And again, it did this not in order. We have the integer 1, correct. We have the string key, correct. And we have the string 2. See how it printed as a string, not as an integer? So this dictionary, again, order does not matter, but it gave me the keys. Now I'm asking it here, print the list dict.values, open and close. Just give me the values, and let's see if it does it. So it gives me tree, this is a value, and apple. And sure enough, it did it properly. And let's see if they're lined up. Now again, the order we saw was screwed up, but index of 0 is 1 in tree, index of 0 is 1 in tree, cool. Index of 2 is apple on the primary one that we created, but now index of 1 is key, but is key still tied to the index 1 of the values? This is a value. It is. So even though the order was flipped around on us in a way, the assignment still stands. Wherever position, whatever index position key is in, you'll find the same this is a value index position appropriately. So this way, if I had a huge dictionary and key was index of 25, then if I went to index of 25 in my values, I would find this is a value because they're always going to be tied together. All right, going through our code here. So now I have 4K in dictionary K1. So again, our dictionary is the primary one that we have written up here. And I have 4K in dictionary K is 1. Print, did this print the keys? Now again, K could have been anything. But I'm saying, and it's going key number 1. And then we're going, it gives me key 2, string of 2. And then we ran out of that loop. So did it print the keys? 1 key and 2? Yes, those are our keys. 1, 2, and key. And then we're doing 4K in dictionary print, did this print the value, dict, and then we're doing open close brackets K. So you'll notice the difference here. I'm just going to run through this real quick 3 times so we can get our values. So we have tree, this is a value in apple. So yes, we got our 3 values. So what was the difference? How did we get the keys and how did we get the values? Well, the K had nothing to do with it per se, but up top, when we're just calling K, we're going to get the keys because think of them as like the primary, the bigger holder. So we're going when we call the main portion of a dictionary, we're always going to get, in this case, K, 4K in dictionary. It's going to give us the keys because that's kind of the primal importance. Without the key, you don't have a value. But now what I'm saying, for dictionary, give me the associated value for each key. So I'm calling key, it's almost like indexing keys. So think of it that way. So for dictionary, if I index K, well, the first K is 1, its associated value is tree. And then the second time it does the loop, 4K in dictionary, well, the index of K is now 1 because we go to the next part, and it's going to give me apple because that's what's in index 1. And then it's going to go index 2. 0, 1, 2. Index 2, the associated value is this is a value. So that's how we can separate between the two as we're going through that. Next line, this is just to show that order means nothing for dictionary. So we have dict2 equals, we're doing a key of 2 tied to value of apple, key of key tied to this is a value, and a key of 1 tied to the value of tree. So what I did here, you'll notice these are the same key value setups as we have in dictionary on line 16, but the order is different. That's all. The order is different. So what we did is the memory is going to create dict2, and I'm curious, did it go 2 key 1? 2 key 1. This one did keep the order. Again, that just happened that way. Dictionaries don't have to keep the order. Now what I'm saying here is order is different, but they are equal. Dict equals dict2. Now again, this is not one equal sign. This is not assignment. This is actual equality, because I'm putting two equal signs in. Excuse me. So is dictionary equal to dictionary 2? So looking at it, we have 1 tree, 2 apple, key, this is a value, 2 apple, key, this is a value, 1 is tree. So the key values are the same, but the order is different. Let's see what Python tells us. Order is different, but they are equal. True, they are equal. So even though the order was different, they are equal. As far as Python's concerned, dictionary equals dict2. And that would make sense, because again, the key value sequence is the same. Just the order in which they're appearing is different. So just out of curiosity, because we're curious beings, does the same apply to a straight up list? So here I have list equals, we create open bracket tree, apple, 1, and love. And then we created list number 2 equals apple, 1, tree, love. So same elements, just different order. So I'm going to F8 through. So of course in memory, it's going to create the list 1 and list 2, or list and list 2 with the appropriate pieces. And you will know that, notice that the order is the same. Tree, apple, 1, love, tree, apple, 1, love, apple, 1, tree, love, apple, 1, tree, love. Lists keep the order. Print, order is different, but are they equal? Does list equal list 2? And Python says false. So the takeaway from this is that dictionaries, the key value will always stay together. They'll travel through order together, but the order of them does not matter. If you have two dictionaries and the orders are different, but the contents of key values are the same, then they are considered equal. They have a Boolean of true. However, for lists, even if two different lists or multiple lists have the same exact elements, but they're in a different order, they are not considered true. So lists, the sequence does matter in terms of ordering. So now we're just going to run down. I just want to show that random is not just for integers, because we do use the random function, or the random library, random.choice and random randint on some of our, when we're doing random number choice, when we're doing some of our other lockout programs that you'll see, and also in Hangman we utilized it. I wanted to show that you can use import random, not just for numbers. You can also use it to pull out different elements. So I have import random, and I have x equals random dot choice. So we're using the random library. We imported it with import. Dot choice is the method from random that we're calling, and I'm applying it to dict2. And again, dict2 up here is our variable assignment. So I'm going to F8 through that, and we get trace back error. And I know exactly why that is. We're going to keep going because I want you to see here in get out of there. I wanted that done, and I'm going to keep rolling, and you'll see, come on. Do I have to run the code? Might have to run the straight code. Am I on split? I'm on split. Write me a sentence. Perfect. So you'll notice normally when we use, when we're using random or randint, it looks more like this, where you have open and close parentheses, and then you have a bracket. So what I want to show, let me quit. Oh no, I want to keep random. Let me hashtag that out so we skip that in our code. And I'm going to do and so we did tree value apple. So that here we go. This is what I wanted to look at. This is where we are right now. So actually, let me close you. And let me move you guys up to the right just so we can keep this all together. So we already had, where are we here? We have so we skipped this. So we're down to when calling the physical directory. So this is where we are in this first part. So what I want to show you is when you do brackets, when you do random.choice, then we have parentheses bracket dict2. it's calling the whole dictionary. It's not calling, and it's not going to be able to pick a random, choose a random word for there because it's calling the entire dictionary. So it's almost as if we had multiple dictionaries. So you can see that what it prints out is one tree key. This is a value to apple. It doesn't pick one of the key value pairs. When we do it for list with the open and close list 2, it does the same thing. It's going to actually call pretty much like the physical list, and it's going to give me the entire list. It's not going to randomly choose any one of those pieces. However, if we do random.choice and I have open and close parentheses and then open close brackets, and we typed in our own string here, our own list with multiple strings and then also an integer, 1, 2, 3, and then 2 integer, random.choice is now going to work. It's going to pick one of the elements inside of the list that we created. And then I have print passing a local list. So local list meaning that we're actually defining it within the brackets. We're not trying to call it from a previous list. And what are we going to get? X is the variable and X is what's assigned to random choice. And it's going to pull 2. And if I ran this again, let's see if it pulls the same thing. It pulls this time 3. So you could see each time it randomly was choosing a different piece altogether. And now let me come back up here. Let me pull you out. Oh, darn it. Amateur hour over here, I swear. Now what this is talking about, returning a sequence of I, we could have got around this, but it's getting tripped up here because if you recall, when it works, you're essentially passing through a list. And here we're trying to say the list is a dictionary. And even if you say that aloud, that doesn't really make sense to you. And here the list is a list, but it's pulling the list. It's not pulling the elements of the list. I'm sorry, up here, where we just have the open and close parentheses. So this is how you don't want to be doing it. This is how you do open and close parents and then open close brackets. But again, this would pull the entire dictionary. If you want the individualized elements to pull your random.choice, that's what you can do. But again, if you were just doing a range, then you could do random.randint and then a range 20 or 0 to 20, however you wanted to specify it. And then it would randomly be choosing your number. All right, guys, well, that's it for today. This was just, again, a little side coding piece. I wanted to run through it because when we're doing the Hangman file, we're going to be using a lot of these in some of our functions, like dot split and some of these properties of dictionaries and not having the order. So I wanted to go through them so that we had it front and center. And when I do the video for Hangman, I'll try to remember that so I can add this as a link so it doesn't get missed by. But I'm going to throw this in probably the 100 days in Python mastery because I think these skill sets, the comprehension of this is huge. All right, guys, take it easy. Have a great day, and I will see you next time.